Hey everybody, welcome back to Math 20-1. We are going to be looking at Lesson 9 today, the quadratic formula. Now in previous lessons we looked at how to solve quadratic equations, and we learned that solving an equation means determining the value of x that makes the statement true. And we learned that we can solve quadratic equations two ways. One was graphically, and we were able to determine that the x-intercepts correspond to the roots or solutions of the equation. And we also learned that we could do factoring by bringing all terms to one side and making them equal to 0. We could then factor and determine when each factor is equal to 0. So let's start by trying to solve each of these by factoring. So we learned that when we are doing these equations, that we can use any method of factoring that works for us. So we're going to look for two numbers, m and n, that multiply together to make 8, and m plus n that add to make 6. Well, we know that 2 times 4 equals 8, and 2 plus 4 equals 6. So here is our factors, which means the solutions are when does x plus 2 equal 0, and that is when x equals negative 2, and the other solution when x plus 4 equals 0, and when x equals negative 4. Let's do this one over here. Same idea. We're going to look for two factors when this equals 0, and now we're going to look for two numbers that multiply to make negative 6, but add to make a positive 3. Well, notice in this case, because this is a negative number, we only have factors like this. Those are the factors of negative 6 that are integer values. So this means we cannot factor this over the integers. That's how we say it. This means that either one, there's no solutions, or we need a different method of finding the solutions algebraically. Well, if we look at the graph of that, we can definitely see that there are solutions, but we can see that they're not integer values, which means if we were to use the calculator, we would have to use the second trace and the 0 feature right here. But I don't want that. I want to do this algebraically. Well, ta-da, there is a way. It's the quadratic formula. Now, as we just saw, some quadratic equations can't be factored. And so we need to use what is called the quadratic formula. And this formula is used to calculate the roots or solutions to any quadratic equation. Now, to start using the quadratic formula, you need to have the quadratic equation in standard form. So ax squared plus bx plus c. And if it's not in standard form, you need to arrange it so that it is in standard form. Now, for the quadratic equation in this form, the solutions are determined. Here we go. This equation right here. So this formula tells us that x equals the b value, negative b value, plus or minus the square root of b squared minus 4ac over 2a Now notice that plus minus. That means that one solution is going to be when we add the negative b to the square root of b squared minus 4ac, and the other one is when we subtract. And that is going to give us two solutions. So let's go back to that one that we couldn't factor and determine the roots using the quadratic equation. Well, in this case, I'll just a equals 1, b equals 3, and c equals -6. Notice that we have to hold on to the signs. So going through this, our first solution, let's do the plus. We're going to say -3 plus the square root of 3 squared minus 4 times 1 times -6. And that's all over 2 times 1. So this equals -3 plus, now we have 9 plus 4 times 6 is 24, all over 2 times 1. And that gives us -3 plus 9 plus 24. Well, that is going to give us the square root of 23. And there we go. We are now having a solution. Now we could put this into the calculator, but we notice it's going to give us a decimal because of this square root of 23. And this square root of 23 is reduced as far as possible. There are no multiples that are perfect squares of 23, or sorry, no factors of 23 that are perfect squares, so we can't pull anything out front and reduce this any further. We can write it this way. The other form that we can put it in is -3/2 plus root 23/2. Either of these are acceptable. So that is one solution, and this one is exact unless we put it in the calculator. So for the second solution, it's going to be exactly the same as this one, but we're going to have the subtract sign between. There we go. Let's move on. Okay, so where does the quadratic function come from? Well, let's look at how they came about getting this from the original equation to that form that we saw above. Well, the first thing we're going to do, we're going to try and complete the square. So that means we're going to factor out a. So notice we bracket off the first two terms and take out an a. And notice we put the b over the a. Remember, we divide when we're trying to figure out what gets left behind inside. So that's the idea. And if we FOIL this or distribute this back in, notice that we're left with ax squared plus bx. So we have this. Remember, now we're going to take the b, which is b over a, divided by 2 and square it. And then we're going to subtract that as well. Now, they've skipped a couple steps here. Let's look at what that is. So notice if this step was here, we would have probably done this like x squared plus b over ax plus b over 2a squared minus b over 2a squared. We would have done that. Then we would have made this part the perfect trinomial first, which is a times x plus b over 2a all squared. And then we would have had this thing sticking off to the side here. And I realize we have this plus c on the outside, just so you know, I didn't forget about it. And now we're going to distribute that through. So we get a times x plus b over 2a squared minus a times, now I'm going to put this square on each of these things here. So that gets me b squared over 4a squared. So notice now using exponent laws, we take that away, and that's where this negative b squared plus 4 comes from. And notice the order doesn't matter with the adding or the subtracting here. The next thing they did here is they took the c value and put it over the common denominator of 4a. So remember, in common denominators, we have to multiply the number by this denominator to get it over. So it would be 4ac over 4a minus b squared. Now we're starting to solve for x, meaning we're isolating the x. So we're going to get this term here over to the other side, and we're going to switch the signs, because this normally would have been, when we brought it over, it would have been minus 4ac minus b squared over 4a. So this negative gets applied here and here. So now the b is positive, so that we put that out front. So now that we have this, we divide everything by a. So we're dividing this by a and this by a. So now we have 4a squared here. Now we're taking the square root. And remember what we talked about, taking the square root. Whenever that happens, we take the plus minus. Now we're left with x plus b over 2a. We're going to subtract this, put it over here. Now notice at the same time what they did. They took the square root of the numerator and the square root of the denominator. And the square root of 4a squared is just 2a. Square root of 4 is 2. Square root of a squared is 2a. So now we have this. Now these both have the common denominator already. So we end up with x equals the quadratic formula. So let's look at a example, and we're going to try to solve it using our three methods. The first one we're going to do is by completing the square. The second one is by factoring and then solving for x. And the third one is using the quadratic formula. So by completing the square, the first thing I'm going to do is bracket off the first two terms. And then I'm going to divide the b by 2 and square it, which just happens to be 1. I'm going to add 1, subtract 1, and there we go. Now, because we didn't have an a other than 1, I can rewrite this with no brackets and have x plus 2. So this part here represents the perfect square trinomial. Sorry, x plus 1. And we're going to minus 1 minus 8. And that's going to give me x plus 1 squared minus 9. Now we're going to isolate the x. We're going to take the square root of both sides. And when we do that, we take the plus minus of 9. And then we're going to subtract 1 from both sides. And that's x equals plus or minus the square root of 9, which we know is 3, minus 1. And if you want, you can write it in the other order. So in this case right here, we have solution 1, which is negative 1 plus 3, which is 2. and solution 2, which is -1 minus 3, which is -4. Okay, let's do this one more time. This time we're going to factor. Well, to factor this, we're going to look for two numbers that multiply together to make -8 and two numbers that add together to make +2. Well, the factors of -8 that would add would be 4 and -2. 4 times -2 is -8, and 4 plus -2 is +2. So our factoring would be x plus 4, x minus 2. But this means that either one of these factors can be equal to 0 and the whole thing would go to 0. So x could equal -4, or we can have x minus 2 equal to 0 and the whole equation would go to 0. And there's that way. And for the last way, we're going to use the quadratic formula. We have an a value equal to 1, a b value equal to 2, and a c value equal to -8. So we have on our x value, the first one, let's just do the positive first. So x equals -b, well, let's just say plus minus for now, and we'll figure that out at the end. B squared minus 4 times a times c. So let's put that in brackets because it has a negative right there. All over 2 times a. Let's simplify. And we get square root of 2 squared is 4 plus 4 times 8 is 32. And we still have that 2 on the bottom. And that's the square root of 36, which is a nice perfect square number. And so we get -2 plus minus 6 over 2, -2 plus 6. So x1 is when we add, so -2 plus 6 is +4. +4 divided by 2 is 2. And x2, when we subtract, is -2 minus 6, which is -8 over 2, which is -4. And let's just go back and we'll just 4 over 2, which equals 2. So notice there's often different ways to do the same equation, but it really depends on you. I want you to think about which way did you like best and explain why. You might use the quadratic formula if you weren't asked for a specific method, because we know the quadratic formula will always give the solutions when they exist. But sometimes factoring can be quicker, as we saw here. And there's a lot of other different reasons why we would choose. Some has to do with what's our best math skills. Maybe we're not super great at completing the square, or maybe we're not super great at factoring. Either way, we have a few different methods to use, and in different cases, depending on the questions, it might be best to use one than the other. But the best way to use the quadratic formula, the best reason, is when we can't factor over the integers. And that means we don't have integer value solutions. So let's keep going. So now we want to solve these equations with quadratic formula, and we want to state the roots as exact values and as approximate values to the nearest tenth. Let's go ahead and do this. So again, let's write down A equals 1, B equals 2, and C equals -1. So putting out our x value is going to be -b. I'll just write out the formula here so you can see it. There we go. So we go -b, not -b, -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times 1. And this equals -2 plus or minus, and we have 2 squared is 4, minus 4 times -1 is plus 4 again, all over 2. And this is going to give us -2 plus or minus the square root of 8 over 2. Now with this square root of 8, well, that's the same as saying the square root of 2 times 4, which equals 2 root 2. So notice I squared root each factor, the 2 and the 4, and I got 2 root 2. So that leaves us with plus or minus 2 root 2 over 2, and that's going to give us -2 over 2 plus minus. Now these two cancel on the last term here, like that, which actually means the first two cancel. -2 divided by 2 is -1. So our solutions are -1 equals plus root 2, and x2 would be -1 minus root 2. Now putting these into the calculator, we get -1 plus second square 2 0.4 to the nearest tenth. And the next one is -1 minus square root of 2. And this is -2.4 to the nearest tenth. There we go. So we have exact values, this column here, this is exact, and these are our rounded. And one more time, let's do it for this one here. Now notice in this one, we do not have it in the form of ax squared plus bx plus c. So we're going to fix that by subtracting 12x from both sides and adding 3 to both sides. And that's going to give us 4x squared minus 12x plus 3 equals 0. So our A is 4, so this one we got some bigger numbers going on. Our B is negative 12, and our C is 3. So putting it into the formula, we get x equals negative b, which is negative of negative 12, which is positive 12, plus or minus. Now the square of the square of b is the square of negative 12, which is 144, minus 4 times a is 16, and 16 times a positive 3 is 40. 16 times 3 is 48. All over 2 times 4, which is 8. Now the square root of 144 minus 48 is the square root of 96. Let's look at getting that 96 reduced. Well, remember this 96. Now let's look at that square root 96. Well, that's 4 times 24 is 96, which is 4 times 6, which is 96. Now notice we got this 4 times 4 here, so that's 16 times 6. So I've just kind of taken some factors, and the reason I'm doing this is because I'm looking at perfect squared numbers, because if I do that, I have the square root of 16 times 6, and that is going to leave me with 12 plus or minus 4 root 6 all over 8. And that's going to leave me with 12 over 8 can be reduced to 3 over 2 plus or minus root 6 over 2. So really what I'm doing here, I'm dividing this by 4 to get 3, this by 4 to get 2, and this by 4 to get 1. So now I have my solutions here, where my x1 equals, we can write it both ways, over 2. My x2 is this. And putting them into the calculator to find the decimals, we get 2.7 and 0.3. So our solution 1, our solution 2 for the first one, solution 1, and solution 2. Okay, so I want you guys to try. If you're the synchronous class and you're working from home, you can feel free to look at this as an asynchronous student. Asynchronous students, please go ahead and email your teacher so far with any questions you have or comments about how you're feeling about the material so far, 3B, 4B, just a quick email to let them know how you're doing. Well, let's look at some examples. A model rocket is fired from a platform 3 meters above the ground, and the height in meters above the ground after t seconds is given by this formula. Describe how you would determine the amount of time the rocket is in the air before hitting the ground. Well, let's remember, if we kind of have an idea of what's going on with this. If this is the platform, it's going to go up, come down, hit the ground. When it hits the ground at this point, think of it as being on the x-intercept. In other words, we need to find the zeros. So we would need, and in particular, we would need to find the x-intercept furthest to the right. So what is the time the rocket was in the air before hitting the ground to the nearest hundredth? Well, we're going to be using the quadratic formula. So let's take our a value to equal negative 4.9, our b value to equal 28, and our c value to equal 3. Well, the quadratic formula tells us that x equals plus or minus negative b, equals negative b, which is negative 28, plus or minus the square root of 28 squared minus 4 times a times c, all over 2 times negative 4.9. So let's get this simplified. So in this case, we're going to get the square root of 784 plus 58.8 all over 9.8, and in particular negative. Now we know that there's no way we can get this in an exact value because we have this decimal under the radical sign. So what we're just going to do is plug this into our calculator with the positive, so negative 28 plus the square root, and then we're going to do the other one with the negative 28 minus. So what does this mean? Well, notice we got this negative 0.11 here and 5.82. And we are talking about time. Now, this graph, and I did actually, this is a bad graph. If I graph this thing, a little nicer here, it actually kind of looks like that, where t represents the time and h of t represents the height. Notice there's this little piece on the negative side. Well, in the context of the question, the time cannot be negative because we're starting after t seconds. So t must be greater than or equal to 0. Now I just noticed I did write x for this here. If you want to change these and make them t, you can go right ahead. I kind of default to x. I think most of us do, kind of like working in there. So that means this cannot be used. So our solution then would be 5.82. So when are we going to be choosing one, both, or neither? Well, again, we have to look at the context of the question. And then from there, we're going to determine an appropriate, that's an N, an appropriate domain. For general type of solve this equation type things, or general solve the equation, we know that the domain for all quadratics equations that are not problem-based is this. So there will be two solutions with an exception. When we're going to get to that in a minute. But in the context of a question, there may be one, there may be two, or there may be none. So let's look at this question right here. We're going to graph using technology and sketch the graph of each equation. So we have these three graphs right here. Now looking at the graph, it's asking us to determine the number of unique real roots for the corresponding graph. Well, this one has two solutions, here and here. This one has one. And notice here, this one doesn't even cross the x-axis. So this one would actually have no real roots that correspond. And this idea of number of solutions, as we talked about in the previous question, there may be 2, 1, or 0. But there is a way of determining how many solutions a problem has before we even start. And this comes from observing and calculating what is under the radical sign in the quadratic formula. This little piece under the square root, this is called the discriminant. And the discriminant gives a lot of information about how many solutions there are. If the discriminant is positive, in other words, if we calculate b squared minus 4ac and it's greater than 0, we know there are going to be two unique real roots. If it equals 0, then the equation has one unique real root. There's still two factors, but they just happen to be the same. This actually comes from a perfect square trinomial. And if we have b squared less than 0 under the negative sign, remember, we can't take the square root of a negative number. Well, then we say it has no real roots. Now, if you're super curious what it does have roots, but they're imaginary. So let's look at those three equations that we looked at before and see how many roots does the discriminant b squared minus 4ac tell us. Well, for this one, we get 1 squared minus 4 times 1 times negative 4, which is 1 squared, or 1, plus 16, which is 17, which is greater than 0, which means we should have two roots. And sure enough, on our graph, it crossed the x-axis twice. What about this one? A equals 1, b equals 4, and c equals 4. Well, for this one, we have, again, b squared minus 4ac. Well, this gives us 16 minus 16, which is 0. So we should have one root. And for the last one, a equals 1, b equals -3, and c equals 4. So we get b squared, which is -3 squared, which is 9, minus 4 times 1 times 4, which is 9 minus 16, which is -7, which is less than 0, which means we have 0 roots. So let's look at a couple more examples, and let's use the discriminant to check the number and nature of the roots for these three equations. So making sure we hold on to the sign, b squared minus 4ac equals, well, b squared is -4 squared, which is 16, minus 4 times 3 times -5. That's going to give us 16. We got minus a negative times a negative is a positive, and we have 3 times 5 is 15. 15 times 4 is 60, which gives us 66, which is greater than 0. So because this is greater than 0, we have two real, unique roots. Let's look at the next one. Well, before we start, we actually have to get that 6 to the other side. So from here, when we determine b squared minus 4ac, we get b is 1, and 1 squared is 1, minus 4 times a, which is -2, times b, c, which is -6. That's going to give us 1 minus 4 times 2 is 8. 8 times 6 is 48. We know it's going to be a negative because we have 3 negatives, which gives us -47. So in this case, because this is less than 0, there are no real roots. And let's look at the last one. This one is already in the form we want, so we're going to go b squared minus 4ac, which is going to give us b squared is -12, which is 144, minus 4 times 4 times 9. 144 minus 16 times 9 is 144, which equals 0, which means we have one real, unique root. There we go. So let's look at the next question, where it's asking us to determine the discriminant for each expression, and then factor the expression if possible. Well, the first one here, we have x squared minus 6x plus 9. That's going to equal 36 minus 4 times 9. And that's 36 minus 36, which equals to 0. That's going to tell us we have one root, which tells me this is a perfect square trinomial. And sure enough, the middle value is 2 times 1 times the square root of 9, which is 3. So this, as a factor, is x minus 3 squared. For the next one, b squared minus 4ac, this equals 9 minus 4 times 3 times 1, which is 9 minus 12, which is a -3, which is less than 0, which tells us this cannot be factored. So there are no solutions or no roots. And I'll say no roots because this didn't actually equal 0. So sorry, let's say that again. It can't be factored. And let's look at this one. 5 squared is 25. Minus 4 times 1 times -7. And this one here is -4 is a positive, so that's 4 times 7, which is 28, which is 5 plus 8, which is 53. Now, this tells us that it's greater than 0, and it does have 2 roots, but remember, this is under a square root sign in the formula. So the square root of 53 doesn't come out to a nice even number. This tells us this can't even be factored. And if we try to find two numbers that multiply to 7 but add to 5, we can't do it. So if the discriminant is positive and a perfect square, then we can factor the trinomial. So even if we can't factor, just to be clear, even if we can't factor it, it doesn't mean there are not solutions. It just means if the discriminant is not a perfect square, there's still solutions, we just can't factor. And let's look at the last one for today. Determine the values of the missing coefficients so the equation has the given number of solutions. One real unique solution. Well, we know that if b squared minus 4ac equals 0, there's one solution. So b squared is 3 squared minus 4 times a, which is 2, times c equals 0. So we're going to solve for c. 9 minus 8c equals 0. Bring 9 to the other side, make it negative, and divide c by 8. So our c value equals 9 over 8. All right, let's look at b. b is 0 equals ax squared plus 6x minus 3. Has two unique real solutions. Well, let's look at that. To have two solutions, it must be greater than 0. So let's put in what we know. Well, b is 6, so 6 squared is 36. Minus 4 times a, we don't know, but c we do know, so we're going to times 3, then times a. And that has to be greater than 0. So we're going to subtract 36 from both sides. And we're going to divide both sides by 12. And that means a must be greater than 36 divided by 12, which is -3. So when a is greater than -3, the determinant will be greater than 0, which means there's going to be two unique real solutions. Now we do have to consider in part B a bit of additional restriction. We notice here that it's saying a is greater than -3. Well, on a number line, we have -3 here, 0, and then goes on from there. That means the solution, or whatever a can be, must equal to the right. But that includes 0. If a equals 0, our equation becomes 0 times x squared plus 6x minus 3, which means this term goes away, which means we no longer have a quadratic equation. So when we're determining these regions where a unknown can be, make a unique solution, when we're looking at a in particular, we must also state that a cannot equal 0. Well, that's the end of our video. If you have any questions, please get in touch with your teacher. Continue to practice in the practice document on the course website. I hope you have a great rest of your day. Take care.